Green AI is not about using less infrastructure. It's more about using the right infrastructure on the right way.
Welcome and thank you very much that you are joining our session, Green AI Behind the Buzzword from Hype to Cloud Reality. AI currently experiences enormous momentum. Everybody speaks about AI, wants to deploy AI. Every vendor promises efficiency, and almost every presentation you will find the word sustainability. But if we speak with the customers, a different picture shows. They ask us, do we really run AI workloads efficiently? Do we control our data? And how we avoid creating massive infrastructure footprints while scaling AI? That we want to discuss today. And how we do move from green AI as a buzzword to green AI in reality. At Yorizon, I'm the head of sales, and as I'm a head of sales, I brought some experts with me, and they know what to talk about. So let me introduce you Sona Emec, the head of AI strategy, and we brought someone from Intel. This is Dr. Markus Leberecht, principal engineer, and I'm very happy that you both are here today with discussing us Green AI Behind the Buzzword. So let's start. Sona and Markus, if the audience can take away one thing from our talk today, what should that be?
Green AI is not about using less infrastructure. It's more about using the right infrastructure on the right way. The biggest efficiency gain today is not alone relying on new hardware. It's more about the right decision according the whole stack, starting from choosing the model to orchestration and utilization. And if that is done right, you reduce cost, energy, as well as complexity at the same time.
Thank you. Markus?
Yeah, from my perspective, it's actually one tagline that I want you to keep in mind. One size doesn't fit all when it comes to green or efficient AI. There's a wide variety of architectural patterns, of architectural scaling possibilities that do require you to understand where to spend your cycles, what workload to map on, and what use case you're actually using. So I'll come back to that point a little later on, but there's actually, from smaller to bigger cases, a place for different differentiated infrastructures.
Thank you, Markus. So, Sona, when we talk green AI, where do the critical decisions start, and when does it become a real business advantage rather than just a sustainability message?
Actually it starts with the use cases. Most enterprise AI today is not about training large models. It's more about inferencing. So things like RAG, Copilot, or agentic-based workflows. And if you take this into account, it will be clear, so where to start. Firstly, it is the architecture. So, for example, using 7 to 13 billion parameter models like Mistral or Llama instead of 70 billion parameter model, if the use case or the task allows it, reduce and providing the same or more or less the same results with less compute power. So from there on, the second thing is the utilization part. Make sure you use your infrastructure efficient as possible. Most environments today, the GPU utilization is below 30 to 40%, which means the most infrastructure or the most paid infrastructure is not participating productively to the value which is created. And the third point, which is, I think, very important to consider, is measurable. So it is important to shift the focus from just raw performance per output to cost and energy per output. This means how much per one useful results you pay and consume, right? So under these conditions, green AI becomes a real business advantage when you produce the same or even better results with less compute, reducing costs, less energy consumption, and in the same time increasing efficiently the scalability.
Yeah, especially when we speak about less energy consumption, then we come into the part of green AI. But Sona, can you give us one example where sovereign cloud infrastructure actually changes how AI workloads are deployed?
Yeah, for example, healthcare. One of our customers, they're using AI diagnostics under GDPR constraints. So for them, it's not allowed actually, or sending data to a non-European infrastructure is not an option. By using our Yexio facilities in Germany and or Austria, they keep the data sovereignty, reduce the governance complexity, and avoiding also to transfer a lot of data, right? So from that perspective, it is the architecture, it is already, I mean, the efficiency is already in the architecture per design. Other part is if we're looking ahead, we see a big potentials for areas like federated training, federated learning. For example, if we stay to the health example, multiple hospitals can use their own smaller, locally trained models on their patient data. And instead of sharing the data, they just sharing the improved model or model learned improvements, what we called gradients, to a core centralized model without sharing the data. That means the core or stronger, larger model is centralized, and the different hospitals just share their improvements, the gradients, right? So in that case, we have more security, data security, also gaining benefits from a larger model in terms of more precise output. And it is also important to consider that in that case, we don't need a central database anymore. So what I mean is, through the access to the central larger model, the knowledge can be shared across the organization without sharing the sensitive data, right? So in that case, I would say the main message here is sovereignty or sovereign infrastructure is not limiting AI. It makes AI, in that case, more secure, yeah, and more precise even, and more efficient.
That sounds great. Thank you, Sona. So let's look here over to Markus. Yeah. Efficiency in AI is not just about software or cloud architecture. A large part of the equation is hardware and infrastructure design. So let's bring you in.
Okay.
From your perspective, working with cloud service providers across Europe, how are most providers currently approaching green AI?
Well, green AI, I would kind of shift the notion there to efficient AI, because green AI without efficient AI isn't
green.
Isn't green. No. And if you think of the cloud business model, cloud provider business model, as converting any cost that a cloud provider has to a pure OpEx for the end customer, it's at the heart of every cloud provider's interest to run any infrastructure, or any service as efficiently as possible. That goes without saying. In terms of specifically AI, the current notion of primarily using GPU clusters for AI inferencing, for example, across the board, is a bit of a challenge there in that case, because we can quite easily show that within that spectrum of use cases, you actually have a quite big portion where you can do CPU-only inference. Specifically, when you take into account that modern processors, small plug for Intel Xeon, have acceleration for AI models in there that are actually packing a certain punch for quite a broad portion of models that exist in the market. So basically saying everyone looks at these type of options, every cloud service provider, because it's in their natural interest. What differentiates there is the way and the timing, when they've started, how they're approaching that, and how far they have come. So I do see this as an inevitable challenge for all of the cloud service providers.
Let's deep a little bit more into the hardware. What role does hardware really play in enabling efficient AI workloads, and where does optimization happen?
Well, so if you take I would phrase it this way. Optimization is in this case a multi-part optimization process in maths. You would say that. So you're not just having to optimize the model you're using, the quantization you're using, the number of parameters of that model. Maybe you're using a distilled model. Maybe you're using multiple models together, which in most contexts is the case. Then you have to orchestrate these on the most appropriate execution units. Sometimes this is done half automatically. Sometimes you need to take that into your own hand. All of that gets then also filtered by your choice of actual execution unit, which I said, where the acceleration for AI is coming from, basically. Yeah.
Thank you to share that with us. Can you share also one example or benchmark that illustrates how infrastructure design impacts performance and also energy efficiency?
Yes, and I can. I just looked it up. Some people may know that if you're ever in the process of purchasing Intel hardware, we have a TCO modeling tool, the Xeon Processor Advisor, and there you can take numbers that are officially benchmarked for different use cases. At the moment, we're revising this tool. It will get a lot of more modern AI tools in there. From the existing ones, I have a slightly dated one, but it's still, I think, pretty revealing. A Llama 2 7 billion model run on Intel Xeon, latest generation. You can basically come down for a typical chatbot use case, to 31 cents per 1 million token in terms of operating cost. That includes the German energy. That's not the US energy taken into account there. For a summarization use case, these are typically a lot more costly when you do that. It's around $1.30 per 1 million token. So it's competitive to run these small models on pure CPU hardware.
Okay, thank you. Now we have two perspectives. The business model was here on that side, and the hardware. So let's bring this together. Is there an uncomfortable truth about the current AI infrastructure market that we should openly talk about? Sona, let's start with you.
Yeah, it's uncomfortable, especially for cloud provider, actually. So the uncomfortable truth is the current, or today, AI infrastructure is mostly overprovisioned. That means we have, if you look to the typical AI workloads, it's mostly summarizing, clustering, or retrieval. And for such AI workloads, we don't need huge cluster GPUs, right? So it is mostly enough to have small architectures, or even to go on a CPU-based infrastructure. So in practical, as we see, most companies use these GPU clusters, and it is more like a default to save their choice. I mean, what I mean is, so they don't know how much the AI workloads are really, and for that, it is secure to have more infrastructure than less. That means they don't consider the real workloads, right? So the consequence is most companies pay a lot for compute and infrastructure, and consume also a lot of energy, where the infrastructure or the computer is not directly used for their value creation. That means the GPU is an idle time, right? So the key message here is, again, a shift of focus, not just going to scale and more compute, more GPU power. No, go to shift it to more efficient system designs where the workloads or the infrastructure used for the proper AI workloads. And for that, you need an idea or even measurables. When do you use what kind of infrastructure for what kind of use cases? So that would be the main message. Please be aware about your AI workloads.
Thank you, Sona. Markus.
My uncomfortable truth is more from the user perspective, namely AI still isn't stable. It's evolving. We've seen the real explosion come when we move from deep learning towards generative AI, with the complexity involved, with the requirements involved. We're now seeing the emergence of agentic AI, which produces at least an order of magnitude more tokens to be processed, and we are at the, I'd say, applied research stage for physical AI, which again adds orders of magnitude of processing requirements on top of it. Do you need everything of that? Possibly, quite possibly not. The uncomfortable truth there is, because this is so evolving, basically buying a GPU cluster is not AI. You need to consider all of the aspects that we talked about before, the orchestration, the creating of the services, the right-sized usage model, etc. All of that together. And I'd actually say it's an idea to possibly, for the use cases you're envisioning, to scan the market and really work with those guys that are dealing with AI infrastructure day in and day out. So it's kind of a call for the right provider will probably help you as an end customer to go that way with efficient AI.
Yes, thank you. And I think you said that very important is transparency and measurable, so that we can measure and that we have the transparency what we use, and also be aware of a user that everything what we do costs us energy. So first of all, do you have any questions to Sona or to Markus you would like to ask to this expert?
So
otherwise, I say
it's open up for questions, and if you don't start, I'll start.
Please
I always have questions, Markus. You should know, right?
I know that. Yeah.
Any questions from the audience? So I'll give you 2 more minutes to think about it, right? I mean, Rock Cafe is known for asking questions, so try hard, please.
You could also say we just talk bullshit. It doesn't matter. We can answer that.
I'm a bit worried about green AI, right?
Okay.
And I don't believe it's going to happen. Why? I mean, if you look at the hyperscalers, right, they're all building their own nuclear power plants, and the consumption of GPUs is rising massively. Nobody's looking at downscaling, right? I mean, Markus, you've been in the industry for years, right? Mm-hmm. Nobody right-sizes systems, right? They all get the big stuff, and then costs explode. And I'm a bit worried that each and every cloud service provider here in Europe is going to build their own small nuclear plant as well, and then consume the electricity as they like. So that's my provocative question.
Yeah.
Right? Is that going to happen?
It's a very good question. And
Can I
you
just
can
my
start.
my independent and also just very personal perspective on that is, yeah, it's an interesting investment wave that is happening that I'm not sure in every case there is actually a well thought out return on investment model behind it. Yeah, that's number one. We'll have to see that. It's obviously a bet on that what I just mentioned, a bet on that rising requirements with new ways to apply AI, the evolution from Gen AI to agentic to physical AI, etc. That's the bet that is happening there. Do I see proof points? Well, I actually see rather proof points for what we just said. Proof points for if you're looking into enterprises that after trying out AI, you kind of land with useful but might I say limited use cases compared with the fantasies in the market. And for those, right-sized infrastructure will eventually come when the controller looks at the stuff.
So you think there's hope?
I think there's hope. Yeah.
There's always hope.
Sona, you think there's hope as well?
More than hope. I think we as Europe have not the resources like US or China, right? I mean, this is clear. We have not the resource, don't have the invest power, we don't have the energy yet, right? So for that, I think we need to go our own way, our own path to solve this issue, right? And we already understand scaling is not the solution for that. For instance, in the next 6 years, we will have around about 60 Yaxios data centers across Europe, right? These are small data centers, 2 megawatt, right? We can scale it up. So with the approach of federated learning, these data centers can be seen as one cluster, and we became a gigafactory. So if the market is there, and if there is a need and demand for core trained models, we would be able to use the idle time out of these 60 data centers to train new models. Yeah? But on the other hand, to build a gigafactory, you need to already have these all market and all demand for these kind of trained models. So I think there is a huge potential and a way where Europe can go, and it is a great idea, right? I mean, we're collaborating, so it is a collaborating approach across industries, across nations. So I think it's the
Well, I mean, that could be an idea, right? To be a bit more smart on the resources, build small AI data centers, what the EU is now doing, and then couple them together if you need the big power, right?
Yes.
Otherwise, most of the stuff is spinning idle. So
Right.
that could be a solution, and it would be a perfect example of the EU cooperating.
Or not.
I mean, I would love to
Let's
see
do
those
it.
things like that, right? Further questions? Yes, please. I'll come with the mic.
I have a question which already relates a little bit to what you just said. And in terms of like having AI decentralized at home, for example, running a model on my own little machine, do you think that's even more energy efficient compared to like those giga AI factories? So if we build like a decentralized like mesh of like our own little AI Mistral model we host, what do you think, what is more energy efficient?
I can just take a wild guess. I mean, it depends very much on the use case. Yeah, we know how efficient SETI at home was for not using a supercomputer, and you could think of similar cases. But yeah, we'll have to see the exact use case. It's certainly not like you'd like comparable to a huge GPU cluster for frontier model training. That won't happen that way, I guess. But in terms of serving many people small requests that mostly stay local, why not? It's an interesting example of distributed computing and federation, if you set it up like that. Yeah, I guess so. Yeah.
Like that like the main workloads are anyways like RAG, for example, like
Yeah.
comprehensive, some text or something, where we anyways don't need the compute power. So
Yeah, exactly. So when people generally are surprised when all of the overhead that you normally have, the orchestration and caching and memory management overhead that you have when you serve a big model for many parallel sessions from a data center, when you compare that with the performance that you get out of a single CPU that you just own for yourself and just run that model only for yourself with a single session. It's fantastic what you can do with even a modern laptop and locally hosted models, yes.
So, I mean, we discussed that last year, actually. So, in the end, the efficiency gain is to utilize or to use idle time, CPU idle time or GPU idle time. And with the federated learning example, we have the data centers. They are more or less in the same GPU or CPU size, right? But you can expand that to think it more on a hierarchical way, where smaller architectures are clustered to a whole system. In that case, for instance, it would be also possible, if you give your resources away, that you participate during a training or inferencing phase, for instance, right? So it is in my perspective, it is a future market how to integrate decentralized different kind of hardware sources and cluster it for such a inferencing approaches. So in that case, the orchestration layer becomes a very unique value creation opportunity for the data centers. And also, you participating with your own hardware, or it is, to the inferencing value creation. Right? So there is also an open window for that. I think it's very interesting, and in the next 2-3 years, we will see a lot of new market concepts according to that issue.
So thank you very much, Sona. And I think before we leave you to the next session, and we would like to thank you to coming here, to listening to us, and we are very happy to discuss further topics to AI, but also, of course, infrastructure as a service on a very sovereign and sustainable way. On the booth Z35 in the Dome, there's Yorizon, and Markus, you will find on the
on the Lenovo booth, we're together with Lenovo is it F01 or something like that, or F02, I think.
And tomorrow at 11, we have a little keynote also to that topic on the COM stage. So thank you very much, and thank you for coming.
Thank you very much.
Thank you for having us.
Big applause. And I think we're going to have this topic on stage the next couple of years, right? It's going to get much more prominent.
I just had a thought. Maybe I can still add that to the topic we had. Don't know if anyone picked that up, but there was the IT news. Was it today, I think, that OpenAI is actually discontinuing Sora because it's way too expensive for them to host that.
Yeah.
Thank you very much.
Thank you.